Question 21, you start off with an equation that looks like this, and you're asked to show that it can be rearranged to give this. When you get this in the exam, you might sometimes, if you don't see how it works straight away, you might have to mess around with it a little bit before you get to this point. But you can try different methods, give yourself space to try it a few times, and then hopefully you can work out the way in which you can rearrange this so it ends up looking like this. Because it's a show that question and they tell you what you're aiming for, it's each step being clear that's going to get you the marks. It's not enough to just write this and then write this on the next line. You've got to show clearly how you get there. But if you end up having to try it a few ways and you end up crossing out the ways that don't work, it doesn't matter as long as you end up with a clear method of how you get from this to this. So if I show you the way in which you can do this, or at least one of the ways, if you add x cubed to both sides, so it looks like that, and then if I divide everything, to make this even clearer, it's worth showing what you're doing. If I divide everything by x squared, 3x squared becomes 3, that becomes 3 divided by x squared, and x cubed divided by x squared gives you x. When it's a show that question, you want your final answer to look exactly as the original, so even though that's the same thing, and you get the marks for that, I'm going to make it as clear as possible. But I've shown the starting point, or you're given the starting point. I've shown one step, which is a rearrangement. I've explained what I'm doing to get from there to there. You've got your 2 marks. Okay, so this is the rearrangement, and they've turned that into an iterative formula. So they've made this x into an xn plus 1, and they've made this x down here into an xn. So it's an iterative formula where each time to get your next term, you're going to sub your previous term into this. And they give you your first term as 3.2. So if you remember in class, if you're given your first term as 3.2, just press 3.2 equals, so it's stored as an answer in your calculator. And then without clearing anything, we've got 3 plus 3 over xn squared. So I'm just going to write in 3 plus, use my fraction button, 3 over answer squared. Because if I press equals now, it's going to substitute in my last answer, which it has stored as 3.2. So it says find the values of x1, x2 and x3. So to find x1, I'll just press equals. Give it as a fraction if you want to be really accurate. The mark scheme, you'll see each term is given as decimals, but if you give it as fractions you should still get the marks. It's just a really accurate version of it. But let's put that to one side. So you can put it in as a fraction. I could say that x1 is equal to 843 over 256. Make sure you've got the perfectly accurate version, and then I'll just write in my decimal version as well. It doesn't tell me any degree of accuracy, so I've just written the whole thing out. If you rounded that a little bit, you'd still get your marks, but unless it gives you a certain degree of accuracy, just round it as little as possible. Don't risk losing marks because you rounded it too much. Just find x2. Because I've used this calculator method, I can just press equals again, which gives me 3.27. I'm just going to write the whole thing out to be safe. Hit equals again, and it gives me my next one. So this is now x3, which is 3.279420685. So I've written out, each time I've hit equals, I've written out the term in full, and now you can see it looks exactly the same as it does in the mark scheme. So whoever ends up marking your paper is not going to be it's not going to be worrying about whether or not they're going to give you 4 marks. They are giving you 4 marks. Okay, part C. Explain what the values of x1, x2 and x3 represent. You cannot write that they represent the different solutions of this equation or the different roots, because that's not true. This is a cubic, and it's a negative x cubed. Sorry, it's a negative x cubed. So you don't, at GCSE, you might not know exactly what this looks like, but a negative x cubed is shaped like this. So it might cut at exactly 1 point where you've got one solution, or it might cut at 3 different points and you might have 3 solutions. It doesn't matter. What you're doing down here when you're using the iterative formula, you're not working out different solutions. Even if it works like this, you're not working out these 3 different solutions or these 3 different routes, which is basically the solutions of this. That's not what you're doing. Just for one of them, you are getting better and better approximations of one of the routes. You are getting closer and closer to the actual routes. So explain what the values x1, x2 and x3 represent. They represent approximations of one of the routes or solutions. They represent approximations of one of the roots or solutions of, and what's our starting equation? We've got 3x squared minus x cubed plus 3 equals 0. So, of 3x squared minus x cubed plus 3 equals 0.